Hi, this is again Dr.Suresh from KIT Coimbatore. Once again, I'm very much happy to meet you all through this video. Today, I'm going to present a video on a practical session how to control the speed of a DC shunt motor, and we will do it practically. I will tell all the procedures step by step and what are the precautions to be taken before going for an experiment. All those things will go by step procedure. Okay. Now, before going to the laboratory, first you have to prepare the regular circuits, arrangements, whatever is there, you have to prepare it. And first, once you come into the lab, you have to make very good precautions, like self precautions of wearing the leather shoes and wearing correct coat, lab coat or whatnot. These are the basic precautions that you have to do before entering the laboratory. After entering into the laboratory, first you have to make a note on a specific machine, what type of machine you are going to do, and what is the specification of the machine. Just you have to make a note first of all. It helps you to just calculate the ratings of the meter to be chosen for doing a machine, and it will help you to calculate the requirement of fuse in order to protect your circuit. So these are some of the basic precautions that you have to do before going to the experiment. As a first thing, as I told you, now let us go and just see the machine, what you are going to do and which machine you are going to do the experiment. Yes, come to the machine, we will see.
Okay, sir.
As I told now, the first you are going to do experiment on a machine called DC motor. This is a shunt motor. First you have to make a note on these specifications. Some of the specifications are first voltage, ampere, and the RPM ratings and the HV ratings. These things are to be noted. So you want to know about the maximum voltage of the machine, you want to know about the maximum current of the machine, you want to know about the speed of the machine, and what is the power rating of the machine and whatnot, and field handling. These are the things that you have to make a note first before going to the experiment. And next you have to choose the type of starter you are going to use. Here we are going to use a DC 3-point starter because it's a DC shunt machine. So choose a DC 3-point starter which is already fixed and it is having the interconnections. In every laboratory this will be done practically before going to the experiment. So these connections you don't want to do. All the terminals of this machine, normally a DC machine will have an armature terminal and the field terminal. The terminal of this machine is already taken to the work table and the terminal of the starter is already taken to the work table. Next we'll discuss about the terminals of the machines which is taken to the work table. Coming to the terminal, this is the main supply, DC supply. It's pure DC 230 volt DC supply which is having the positive polarity and the negative polarity, which is protected by MCB, and it is like a switch. And after that, these three terminals say L, A, F or the starter terminals, which is already taken here from the starter to the work table. And these terminals called A, that is armature terminal, A, and the field terminal of the machine F. So we have these four terminals which is taken from the machine and it is already located in the work table. And these things we are not going to discuss. This is going to be AC supply which is given for some other purposes. This is the first setup you have to do. The next, you want to choose what is the range of meters that you are going to decide for doing this particular experiment. I told you the experiment is speed control of DC machines. In order to do the speed control, what are the basic apparatus required? You have to select, and what is the specification of the apparatus that you want to do? You have to select it. So next I will tell you how to select a apparatus for the particular machine, because already we got an information about the nameplate details of the machine. From the nameplate details, we have to decide the meter requirements.
Sir.
Yes. Now we will go for the apparatus required for doing the machine. So these are the apparatus required for doing this particular experiment, speed control of DC shunt motor. First we have to know we have to select an ammeter, we want an voltmeter, we want an rheostat, or what we call this a variable rheostat, one for controlling the field and another rheostat for controlling the armature. So we can do the control of speed in DC machine by two methods, one by armature control method as well as by field control method. Therefore, we need two different rheostats to be connected in the field circuit of the machine as well as in the armature circuit of the machine. And we need to measure the speed, so that we need a tachometer. So these are the materials or apparatus required for doing this particular experiment. And next, as I told you that specifications of the machines, of the meter, you have to know. So since we are doing this experiment on no load, in no load, the machine is not going to take more amount of current. Therefore, we need to select a current of low amperes, that is 0 to 2 amperes, because we are doing this experiment in no load condition. And voltmeter, this is to measure the voltage across the terminals of the armature or voltage across the terminal of the machine, 0 to 300 volts. Coming to the rheostat, we need two rheostat. One rheostat is connected in the field circuit as well as one rheostat is connected in the armature circuit. In field circuit, normally the field ohms, the resistance of the field should be very high, as if the resistance is high, automatically the current goes minimum. Therefore, 300 ohms bar 1.7 or 1.2 or 1.5, anything you can select. And coming to the armature rheostat, armature rheostat will be normally low, because if the resistance of the armature is less, automatically the current in the armature will be high. Therefore, we are selecting 50 ohms and 5 amperes for our specification of the machine which we are selected. And next, we will come into the circuit diagram of the machine. This is the circuit diagram shown here. This is the circuit diagram shown here for control the speed of the machine at no load. So basically it starts from the supply, it's positive and negative. We have the supply 230 volt or 220 volt DC supply. From the DC supply, we are tapping the power to the machine. For that, we need a switch. So we are using double pole single throw switch for tapping the power from the supply to the machine. After that, we need a protective device, or we are using fuse, or nowadays we are using some circuit breakers or miniature circuit breakers. So we have to calculate the fuse ratings based on the specification. Since the machine current is 19 amperes, the maximum current of the machine at the armature side is 19 amperes. So we are taking almost 19 amperes of current is the maximum current of the machine. Therefore, choose the fuse ratings as 125% of this rated 19 amperes. So approximately this will be equal to 25 amperes. So that is chosen here as 25 amperes. And now after this, the connection goes in such a way that first you are using a starter. As I discussed earlier, these terminals are already in the buck table. Starter has 3 terminals: load or line. This is going to be connected. F is for field and A is for armature. So for controlling the armature, we have to connect an rheostat or the resistance 50 ohms for 5 amperes, as we selected earlier in the apparatus required. These 50 by 5 amperes is connected to the armature of the machine. And next, one more 300 ohms bar 1.7 amperes, 300 ohms bar 1.7 amperes is connected in the field of the machine. So one rheostat is connected in the armature, one rheostat is connected in the field. This is going to control the field and this is going to control the armature. By two different controls, we can achieve different speed controls. One called the higher level, that is from the rated speed of the machine, the speed may be increased to some extent by controlling the field rheostat, and by controlling the armature we can control the speed of the machine from the rated to the below speed to some extent. Why we are doing this, that we will discuss later. And we need to measure the voltage across the armature. Therefore, we are connecting a voltmeter in parallel with the armature terminals. At the same time, we want to measure the field current of the machine. Therefore, we are connecting an ammeter in series with the field. So this is the complete circuit diagram or a basic simple circuit diagram which is required for controlling the speed of the machine. Okay, and next we will proceed with the some questions. I want to ask you some questions to the students. We proceed with the questions and we'll start the machine and we'll take the readings and we'll go for the calculation. Okay. So next I told you that I want to ask you two questions. Question number one, what are the two methods of speed control? Question number one, what are the two different methods of speed control? And question number two, why we are preferring a particular speed control for higher level and particular speed control for lower level of speed control? These two questions, who is going to answer? First question, what are the two different types of speed control? Come on. Field control method, armature control. So it means there are two different control methods. One is field control method, number two armature control method. Good, it's a good answer. The next question, why we are preferring armature control method for the particular level of speed and why we are specifically going for the field control for the particular level of speed?
Because the general equation of our speed control test is N is equal to EB by 5. EB in sense it is a back EMF. Here we can control only the voltage. The limited voltage is for only 230 voltage. We can't raise the voltage above than that. So that is compulsory, we have to reduce the voltage. If we reduce the voltage, definitely the speed will also reduce because N directly proportional to the speed.
It's a good answer. And similarly, we will go for the field control. Just I want to explain very clearly, and the answer is very right. As she said, N is directly proportional to EB by 5. N is directly proportional to EB by 5, where EB is given by the equation V minus of IA or A. Here, IA is at no load, so it is going to be very negligible or minimum, so we are going to neglect this thing, and therefore, the control at no load is basically taken over by the voltage. For the machine, as I said, the maximum voltage is 230 volt. This is the maximum, which is directly proportional to the speed. Now, we have the chance or possibility to control the voltage only the below. It means that if we can reduce it for 220, we can reduce it for 210 or whatnot. We cannot go beyond 230, that is 440 or 250 like that. It means that we are raising the voltage above the rated level which is already specified in the machine. The maximum is 230. Therefore, the possibility is only to reduce the voltage. If you reduce the voltage, automatically the speed will getting reduced. Therefore, this armature voltage method or armature control method is adaptable for reducing the speed. Wherever you want to reduce the speed of the machine, then go and select armature control method. Similarly, here EB is indirectly proportional to phi. So phi is the flux in the field. It is the flux produced by the field current. Here already the field current is maximum because at the rated condition it is maximum. That is because flux is directly proportional to field current or I. If I is maximum, flux is maximum. If the flux is maximum, speed is minimum. Already the current is maximum, then we have no chance to increase the current more than the rated. Therefore, we have only option is to reduce the current. If you reduce the current, automatically flux will get reduced. The flux is getting reduced, automatically the speed will increase. Therefore, field control method is only chosen for the speed where we need the speed above the rated speed because we are reducing the flux. Therefore the speed is increasing. Do you understand? Yeah. Now this is the basic thing we have to understand before going to the experiment. Do you have any doubt as for our discussions? Now you have any doubt?
What's the field index?
Yeah, that's what I discussed about the field positions, and now we will go and do it practically. First you have to make a connections as per the circuit diagram. So the connections are made as per the circuit diagram, and we have to take a precaution which is very important before starting the experiment. Here in our case, we have two different rheostats, and these rheostat position should be checked or verified before starting the experiment. In our case, the field rheostat should be in the minimum position. Here the field rheostat is in the minimum position, and the armature rheostat is in the maximum position. So here the action, it is in the maximum position. So this is the first precaution you have to take it, and the second precaution, choose for the loose connections in the meters as well as the terminals. Once if you satisfy with the precautions, then we can start the experiment directly. Okay. So now we'll start the experiment. As we checked once again, the connections are made perfectly. I assume and I conclude that the connections are perfect. Now we are going to start the experiment and we'll start doing the experiment and take the readings. I'll tell you how to take the readings. Okay. Now we'll start the experiment. Okay, now I assume that the connections are perfect as the precautions are very good. We verified once and twice, and now we are going to switch on the machine. First, switch on the main. The main is switched on, so that the power is, we are receiving the voltage 230, the power is alive here. The next, you have to make use of the starter and just start the machine by using the starter. Gradually raise the holder in steps. Please listen once again how I am doing. Gradually rise, therefore the machine is starting here and slowly it's picking and the starter is hold now. And the next we are going to vary the rheostatic positions. Here first we have two different, first we have to make an armature. I think this is connected to the armature terminal. This is connected to the armature terminal. Alright? Yes. Okay. So first cut the armature rheostat in steps and raise maximum. So you can witness that the machine speed is increasing in steps slowly. The sound itself indicates the machine is increasing in speed. Now measure the speed. So if we measure the speed, take a tachometer and just measure the speed here. I am just measuring the speed. It's 1300 RPM. It is not the max. It is not the specified speed. Therefore, I am just controlling the field rheostat in steps. So raising the speed to some steps. I am just measuring the speed again. Now it is 1444. Gradually rise in steps. It's 1500 exactly. Okay. So this is the position. The machine is running at the rated conditions. At that time, the field current is almost 1.3 amperes, and the voltage is exactly 200. The voltage is exactly 220 volts. This is the first preliminary step we want to do, and we have started the machine. We just make the machine to run at the rated conditions. This is the first step. Next, we will slowly, gradually increase the voltages, adjust the control. That is, we have two different controls. One is armature and another one is speed. Gradually make this one constant and vary this one, and take some set of readings. And next, make this one as a constant and just vary this one and make second set of readings. After taking the set of readings, plot a graph. From the graph, we can understand the speed control is achieved in two methods. One, field control is used for the higher level of speed control, and it means above the rated speed, and the speed control which is used for the armature is used for below the rated speed. Okay? Are you clear? Yes.